Okay, so when we're looking at the ECG, another thing we're going to do is take a look at what we call the axis of depolarization. And basically all that means is if we have our heart and we're just looking at the left ventricle, is it depolarizing in the right direction? All right. And so a way we can do that from a frontal view is to use the limb leads. In particular, we want to see if it's going from right to left. All right, so our limb leads from right to left. And so, hey, we could use lead one for that, right? Lead one tells us if it's going from right to left. Is it going from top down? All right, so we need a lead telling us if it's going from top down. A great lead for that is AVF. AVF tells us if it's going from top down. So the limb leads are very useful in this case, and because the heart might be a little shifted this way, or maybe a little shifted this way, or maybe there's just electrical issues, a bundle branch block, something where the electrical activity just isn't traveling the right direction it should be. Okay, so looking at the axis can tell us that. And so that's what we're going to do here. We're gonna figure out how do we look at the ECG and determine if the ventricle truly is depolarizing in the direction it should be. And so again, this idea of looking at lead one, okay, to see if this is going from right to left, because in lead one, this electrode is negative, this electrode is positive, and lead one will tell you if it's going that direction. AVF, right, like lead two and lead three, but AVS in particular is used to tell whether it's going in the top-down direction. I've got a little bit of a lag here in my pen. Is it going top-down? So you can see here, now I have XY coordinates pretty much. And so what do we normally see? What does a normal ECG look like? And when we look at an ECG, now I've got a normal one here. I'll show it to you real quick. What should this look like? So here's leads 1 through AVF. So we're really just looking at lead 1 up here and lead AVF down here. And so in lead 1, we typically, remember, we have upright waves. R waves that are bigger than the S wave. And that's something we're looking for is overall, is the QRS complex more positive or more negative? And so in 1, it's more positive, okay? And if you were to look at AVR, even though we're not, obviously the QRS complex in AVR is more negative, and it should be. But what about in AVF? In AVF, we have a much more positive QRS complex, and we should. So here we have a positive QRS complex in 1 and a positive QRS complex in AVF. So let's go back to our graph. And what does that mean? We had a positive in 1, so it means we're going to be somewhere over here in these quadrants here. Okay, these are positive for lead 1. Over here would be negative for lead 1, and we're not. So in this quadrant, these quadrants, so we're in one of these two quadrants, and it was positive in AVF. That means if it's positive in AVF, then we're somewhere here in the bottom. And so where do we have our overlap? Right here. And so if you have a positive QRS, so it's overall positive, you have to take the negative deflections and the positive deflections, add them together, or compare them. So if I had 2 millimeters of positive R, but I had 3 millimeters of a negative S, then it's mostly negative. But if it's a positive QRS in lead 1 and a positive QRS in AVF, so a positive 1 and a positive AVF is this arena right here, that means it's depolarizing in this direction. And that is normal axis deviation. Normal axis deviation. That just means it is depolarizing in the right direction. Now we can be more specific. We could break this down with all the limb leads, and we could add 30 degrees, and we could really start to calculate very specifically, which in some cases is important, but we're not going to cover that. We're just going to do the 4 quadrants. Is it normal axis deviation? Now, what if in lead 1 I had something like this? So it would be, that's mostly negative. But in AVF, I still had something like this. And so you can tell if I measure that R wave is bigger than the S. And so this is mostly positive. So a negative in 1 would put me, and I'll change colors here. Actually, we'll just redraw it. We'll redraw it. So this is AVF. And here's 1. So a negative in 1 would be these quadrants. But a positive AVF is these quadrants. So where's my overlap? It's here. And so this is a right axis deviation. That means for whatever reason, the overall depolarization of the heart, it's going down because it's going towards AVF, but it's going towards the right, right? Because lead 1 should go this way, and AVF is going this way. So this one's going down, but it's not going towards the positive one, it's going away from it. So it's going to the right. It's deviated to the right, right axis deviation. So hopefully you can see that now. So that's right axis deviation when you have a negative in 1 and a positive in AVF. So again, the key here is if you can draw this and then you look at 1 in AVF on the ECG, you can quickly give a basic idea of what the axis deviation is. So let's cover our 2 other options then, right? We have 4 quadrants here, so we have multiple options. AVF, positive here. Lead 1 goes right to left. It's positive here. So let's assume that this time in lead 1, I look at it and I see something like this. Well, it's mostly positive. So I got a positive in lead 1. When I'm looking at AVF, I see something like this, and I add it up, and whoa, that's mostly negative in AVF. So it's going away from AVF positive electrode, so it's staying up here. But it is positive in 1, so it's over here. And I have this particular area here that is left axis deviation. So let's see if that makes any sense. So our heart, if we draw our heart here, that means we're not going towards the AVF positive electrode. We're going away from it. So instead of going down, we're going up. So it's going up, okay? But in lead 1, it was positive, so it's not going just up, it's going towards the right. So it's going this direction. So why would it go in this direction? Well, the heart's probably not sitting like this. It's probably shifted, and so it's going like this. So that's normally how the heart depolarizes, right? Through the ventricles. It's just the whole heart is shifted so that it's going towards the electrodes that we put on the surface of the body, and it's going away from AVF. It's going towards that positive electrodes. Why would that happen? There could be a lot of reasons. It could be usually short, more stocky people. If the organs push up, or maybe there's something internally going wrong, push up on the heart, it might do that. There's a lot of other reasons too. Remember, this doesn't tell us physically what's going on. It's just electrically what could be. And electrically, it could be a lot of things, conduction defects and so on. But it could also just be a physical adjustment. People who are tall and thin tend to have more of a right axis deviation where the heart shifted down and it's turned because they're tall and thin, and that just is the way the heart fits a little bit better within their anatomy. So, you know, there's a lot of different reasons why some of these things exist. Now, there's one more, obviously, and without making this video any longer than it needs to be, if you're going away from lead 1, right, you're going this direction, and you're going up, you're going away from the AVF, right? So where are we here then on our axis? If we're negative for 1, we're over here, and if we're negative for AVF, we're up top. and that's over here. And there's a couple of names for this. This means a depolarization that's going the opposite direction of what it should be. One, it could just be indeterminate. We're not really sure what's going on. Indeterminate. Or extreme axis deviation. It's got an extreme axis. It's completely backwards of what it should be. That's another possibility. So let's just take a look at another one and see what we get here. So if we look at this ECG, remember we're looking at lead 1, and so we have a small r but a big S. So lead 1 is mostly negative. And we go look at AVF, same case, very small r if any, and a big S. So in this situation, all right, we actually have an extreme axis deviation for this ECG here. Okay, so axis deviations are something you could quickly and easily do just by looking at leads 1 and AVF, because that'll tell you if it's going left or right, up and down. And so from a frontal plane situation, we can see if it's depolarizing the way it should be.